Bismillahirrahmanirrahim. Assalamu alaikum, students. In the last lecture, we discussed the Doppler effect in sound and we wrote the general formula. I will continue with that. The Doppler effect in sound. Continued. We have already discussed the general formula. I will write it. It is written as nu prime is nu times V plus minus VO over V minus plus Vs. So this is our general formula. You know, nu prime is observed frequency or apparent frequency. Observed frequency. Nu is actual frequency, sometimes called real frequency, and V is the velocity of sound. P naught is actually VO is the velocity of the observer or listener. Vs is the velocity of the source. And you have to take the proper sign as already discussed in the numerator and denominator depending upon the situation of the problem. And remember, we are observing all this or expressing all these velocities related to a reference frame at rest in the medium through which the sound travels. Now, based on this general formula, now we will together solve a problem that will cover all the cases. Let me write the problem. So this is our sample problem. So it goes like this. Let me use this color. Problem says the siren of a police car emits a pure tone at a frequency of 1125 Hertz. Find the frequency. Find the frequency that you would perceive in your car under the following circumstances. Party says your car at rest. Police car moving toward you at 29 meter per second. And we have situation B. Police car at rest. Your car moving toward it at 29 meter per second. Then we have situation C. You and the police car moving toward one another at 14.5 meter per second. Then we have situation D. You moving at 9 meter per second. Police car chasing behind you at 38 meter per second. Now let us move to the solution. And before going to the solution, let me check the problem first. I will repeat the problem. The siren of a police car emits a pure tone at a frequency of 1125 Hz Find the frequency that you would perceive in your car under the following circumstances. Part A, your car at rest, police car moving toward you at 29 meter per second. Part B, police car at rest, your car moving toward it at 29 meter per second. Situation C, you and the police car moving toward one another at 14.5 meter per second. Situation D, you moving at 9 meter per second. Police car chasing behind you at 38 meter per second. Now all the four situations or four parts in this problem can be solved using the equation we discussed. That is this one, equation 1. Let us proceed. Part A. Here VO is 0. Why? Because your car is at rest, right? So observer velocity is 0. Because part A says your car at rest. You are the observer of the sound wave, so observer velocity is 0. So VO is 0 and VS is, I will use another color, VS is 29 meter per second, right? Because police car is moving toward you at 29 meter per second and siren is fixed in the police car. So velocity of the source is 29 meter per second. Now we choose in our formula, we choose the upper minus sign in the denominator of equation 1 because the police car is moving toward you, right? So we thus obtain we therefore obtain using V equal 343 meter per second. What is V? It is the speed of sound in still air. So we use V equal to 343 meter per second for the speed of sound in still air. So nu prime is equal to nu times V over V minus Vs. What is nu? This is our nu 1125 hertz. So this is 1125 hertz times 343 meter per second over 343 meter per second minus 29 meter per second, right? 1125 hertz for nu, 343 meter per second for V. Then in the denominator, we have 343 meter per second minus 29 meter per second for Vs. When you solve for it, you get 1229 hertz. This is your perceived frequency in situation A. Let me encircle it. $12.29 hertz. You can check the numbers at home. Let us move to situation B. Situation B says police car at rest. So in situation B, Vs is 0, right? Your car moving toward it at 29 meter per second. That means observer velocity is 29 meter per second, right? So let us solve part B. In this case, Vs is 0 and Vo is 29 meter per second. Now let us move to the equation. This is my equation. Now this Vs is 0. So in this equation, what we do, we choose the upper plus sign in the numerator because you are moving toward the police car, right? So we have nu prime is equal to nu times V plus Vo over V. Let us put the values. This is 1125 hertz times 343 meter per second plus 29 meter per second, and in the denominator we have V, that is 343 meter per second. Check it. When you solve it, you will get 1220 hertz. So this is the frequency perceived by you in situation B, 1220 hertz. Now let us move to situation C. Let me use this color. Now situation C, let's move to the question. You and the police car move toward one another at 12.5 meter per second. So both are moving towards each other. So in this case, Vs is equal to 14.5 meter per second and Vo is equal to 14.5 meter per second. Vs equal to 14.5 meter per second and Vo both are 14.5 meter per second. Now what about the signs? We choose the upper signs in both the numerator and denominator of equation 1. That means in the numerator we have to take plus sign and in the denominator we have to take the minus sign because you and the police car are each moving toward the other. So we therefore obtain we have nu prime is equal to nu times V plus Vo over V minus Vs. V plus Vo over V minus Vs. Let us substitute the numbers. It is 1125 hertz times 343 meter per second plus 40.5 meter per second over 343 meter per second minus 14.5 meter per second. 343 meter per second plus 14.5 meter per second in the numerator and in denominator 343 meter per second minus 14.5 meter per second. So when you solve it, you will get 1224 hertz. So this is your perceived frequency in situation C. Let me encircle it. Nu prime is 1224 hertz. Let us move to situation D. Here, let's move to the question. You moving at 9 meter per second, so Vo is 9 meter per second, and police car chasing behind you at 38 meter per second, so Vs is 38 meter per second. Vo is 9 meter per second and Vs is 38 meter per second. Now you are moving away from the police car. So in equation 1, general equation 1, we choose the lower minus sign in the numerator. But the police car is moving toward you, so we choose the upper minus sign in the denominator. I repeat, you are moving away from the police car, so we choose the lower minus sign in the numerator, but the police car is moving toward you, so we choose the upper minus sign in the denominator. So we have nu prime is equal to nu v minus vo over v minus vs. Let us put the numbers. V minus vo over v minus vs. 1125 hertz. Then we have 343 meter per second minus 9 meter per second. In the denominator we have 343 meter per second minus 38 meter per second, right? Numerator 343 meter per second minus 9 meter per second. In denominator we have 343 meter per second minus 38 meter per second. So when you solve it, you will get 1232 hertz as your perceived frequency for situation D. (1232 hertz). Now there is a note. In all four cases, if you check it, in all four cases in this problem, the relative speed between you and the police car is the same, namely 29 meter per second. But the perceived frequencies are different in the four cases. I repeat, in all four cases, let me write it, then, so note, or I should go to next page, important note. What is important note? In all four cases in this problem, the relative speed between you and the police car is the same, namely 29 meter per second. But the perceived frequencies are different in the four cases. Let me make it clear to you. In situation A, you are at rest, police car is moving toward you at 29 meters per second. That means relative speed between you and police car is 29 meters per second. Right. So here, police car is moving toward you, you are at rest. That means every second, the gap between your car and police car is decreasing by 29 meters. In situation B, police car is at rest, your car is moving toward it at 29 meters per second. So same is the situation. Relative speed between you and police car is 29 meters per second. In situation C, you and the police car are moving toward one another at 14.5 meters per second. The gap between you will be decreasing at 29 meters per second at the rate of 29 meters per second, right? Because you and police car are moving toward one another at 14.5 meters per second. So in order to get the relative speed between you and the police car, you have to add 14.5 meters per second with 14.5 meters per second, you will get 29 meters per second as relative speed between you and the police car. And situation D, you moving at 9 meters per second, police car chasing behind you at 38 meters per second. So relative velocity between you and police car is 38 minus 9, which is 29 meters per second, right? So in all the four cases, the relative speed between you and the police car is the same, that is 29 meters per second. But if you see, the perceived frequencies are different in all the four cases. In situation A, perceived frequency is 1229 meters per second. In situation B, it is 1220 hertz. In situation A, it was 1229 hertz. Here it is 1220. In situation C, it is 1224. In situation D, it is 1232. So you need to note that the Doppler shift for sound is determined not only by the relative speed between source and observer, but also by both of their speeds related to the motion medium that carries the sound. We write it in this color. Therefore, the Doppler shift for sound is determined not only by the relative speed between source and observer, but also by both of their speeds relative to the medium that carries the sound. It's important. You need to understand it and remember it forever. And you will check all these calculations at home. Check whether this calculation is right or wrong. Check all the numbers at home. I will give you now a homework problem. So this homework problem is a question. It goes like this. A whistle of frequency 538 hertz moves in a circle of radius 71.2 centimeter at an angular speed of 14.7 radian per second. What are part A, the lowest, and part B, the highest frequencies heard by a listener, a long distance away at rest with respect to the center of the circle. Let me check the problem and repeat it for you. A whistle of frequency 538 hertz moves in a circle of radius 71.2 centimeter at an angular speed of 14.7 radian per second. What are the lowest and part B, the highest frequencies heard by a listener a long distance away at rest with respect to the center of the circle. This is all for today. Go through all the video lectures. Don't waste your time. Do your homework, work hard, and don't forget to subscribe and like my channel. You can also comment. Thank you. God bless you. Assalamu alaikum.